Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will start lecture number 3 of numerical analysis. This lecture number 3 is regarding differentiation using approximation, numerical analysis. So let us start this chapter. Chapter name is numerical differentiation, and this chapter we need to know about some basic things. The first one is derivative of a function f of x with respect to x. So derivative of function f of x with respect to x is denoted by d dx of f of x. Yeah, or you can say that d by dx of f of x. So d by dx of f of x can also be denoted by capital D of f of x. It means that d dx or d by dx is denoted by capital D. So you can write capital D instead of d by dx. Or the third one is a prime notation. For example, that is the first derivative of f of x. So you can denote this derivative by f prime of x. So remember these three notations which will be used throughout this chapter. So don't be confused in these notations. All these three notations have the same meaning, which is called derivative of f of x with respect to x. The second one is exponential function e power x. So e power x, you know what is e? That is actually an irrational number, which is the base of a natural logarithm. So we don't need to know about that thing, but we need to know about the series form of e power x. So e power x in series form and expanded form can be written as 1 plus x square by 2 factorial, x cube by 3 factorial, x4 by 4 factorial, and so on. So you see here that whatever the power of e is, that is x. So if instead of x there is d, so replace x by d here. That will be 1 plus d square by 2 factorial plus d cube by 3 factorial, and so on. If the power of e is, say for example, hd, so replace x by hd, and so on. So that is the series expansion, that is the expansion of e power x, and this expansion is regarding Maclaurin series expansion. Anyways, the third one is Taylor's series expansion of a function of x plus h. F of x plus h can be expanded by Taylor series in the following form, and this form. You see that f of x plus h, when we expand this function, so that will be equal to f of x plus h, this h plus h into f prime x. Remember that if there is one prime of x, of f of x, then the power of h will be 1. So that is 1 divided by 1, you can say that. But if there are two primes, that is f double prime x. F double prime x means this is the second derivative of f of x. So we will multiply h square by 2 factorial with f double prime x. And when there is f triple prime x, then we will multiply h cube by 3 factorial with it, and so on. That is called the Taylor series expansion of a function f of x plus h. And the fourth one is the shift operator e, which you have studied in the previous chapter, that whenever a shift operator is applied on a function, so a step will be added in that function. we see here that whenever e is applied on f of x, so that will become f of x plus a step size h, where h is the step size. So if there is e square, so that will become 2h. If that is 3e cube, so that will become 3h, and so on. All these four notations will be used in a very short question. We may say example, and this example was included in the previous papers, university papers, that find the relation between the shift operator E and differential operator D. Capital D is actually the derivative of the function, that is called differential operator, and E is the shift operator. So what is the relation between these two operators? Let us find that relation. As we know that when shift operator is applied on f of x, so that will become f of x plus step size x plus h. You see that the right hand side of this equation, which is f of x plus h, that is f of x plus h, this can be expanded by Taylor series expansion. So expand the right hand side of this equation by Taylor series, we'll get this equation, that is e of f of x, and the expansion of f of x plus h is this whole series with the help of Taylor's. So we have studied this thing in the last topic notes. So that is the expansion of f of x plus h. Thirdly, we may write f prime x is derivative of f of x. We have studied three notations for derivative. The first one is d by dx or d dx. The second one is capital D, and the third one is the prime notation. So this prime notation is written in the form of capital D, which is d of f of x. Similarly, f double prime is d square, f triple prime is d cube. We see that in this equation, f of x is common in all those terms. So this f of x is common, so we have taken f of x common from all those terms. It means that 1 plus hd plus h square d square divided by 2 factorial plus h cube d cube divided by 3 factorial, and so on, whole multiplied by f of x. And the other step, 1 plus hd plus hd, this can be written in this form. H square d square can be written as hd whole square. H cube d cube can be written in this form, hd whole cube, and so on. 1 plus hd plus hd whole square by 2 factorial, hd whole cube by 3 factorial. This is the expansion of e power hd. So that is e power hd into f of x. So it means that e into f of x is equal to e power hd into f of x. So it means that the effect of e on f of x is the same as the effect of e power hd on f of x. So cancelling f of x from both sides, we'll get e is equal to e power hd, and this is the required relation between e and d. What does it mean? That e is equal to e power step size into differential operator. This question was included in the previous papers, university papers, so many times, and that is a very simple question. Try to remember this example in your mind. This slide is about the nodes, some specific nodes. We know that xp is x naught plus ph in the previous chapter, that xp is equal to you don't need to remind these hints, but one thing should be remembered, which is the last step of these nodes. So I'm coming towards that step. So when xp is equal to x naught plus ph, and whenever we differentiate this equation with respect to p, so whenever we differentiate this equation with respect to p, so x naught is a constant number, so derivative of x naught will be 0, and derivative of ph with respect to p, the derivative of p is 1 and this is h, so that is 0. I mean, derivative with respect to p of x naught is 0 plus derivative of p is 1 and this is h, so this is equal to h. It means that d by dp of xp is equal to h. Now apply f on both sides of this equation, so that will become f of xp is equal to f of x naught plus ph, and differentiate this function with respect to p. So apply d dp on both sides. We see that this thing d dp of f of xp can be written in this form. We have split this derivative by chain rule. This can be cancelled out, and the same d dp will be here. So that is d by dxp of f of xp into dxp by dp is equal to f of this whole thing is equal to xp. This thing can be denoted by f prime, so that is f prime of xp, and dxp by dp from this equation, dxp by dp is equal to h. Replacing this dxp by dp by h is equal to d dp of f of xp, and the last one is dividing both sides by h, this equation, so h will be cancelled out and this is 1 by h. So 1 by h of d dp, this can be denoted by fp, so it means that f prime p is equal to 1 by h multiplied by d dp of fp. So f prime is this thing. If there is double prime, so 1 prime will be increased here. If this is triple prime, so 2 primes will be increased here, and the same thing, there is h. If there is 1 prime, so this is h. If there are 2 primes, so that will become h square. If there are 3 primes, so that will become h cube, and so on. So that is the relation. Remember this last equation. Numerical differentiation. Numerical differentiation. Differentiation means derivation, derivatives. Numerical means approximate. Approximate differentiation is performed using the following techniques. These techniques are already studied in the previous chapter, so you don't need to worry about these techniques, because these techniques are the same as you have applied in the previous chapter. You just need to differentiate those functions with respect to p. The first one is Newton's forward difference interpolation formula, already been studied. Backward difference interpolation formula, Stirling's formula, Bissell's formula, Everett's formula, Gauss forward formula, and Gauss backward formula. So there are 7 formulas to make numerical differentiation easy. These formulas are already studied at the previous chapter. You just need to differentiate those functions with respect to p. How could we differentiate those functions, those formulas with respect to p? Let us start from the next slide. The first one is derivatives by the use of Newton's forward difference interpolation formula. This is what we called Newton's forward difference interpolation formula, already been studied at the previous chapter. We just need to multiply these terms, multiply p inside, multiply those factors, and multiply those factors to get this equation. Now differentiate this equation, this formula, with respect to p. With respect to p, remember that with respect to p, we'll get this equation. So we'll get this equation. The derivative of f naught with respect to p is 0 because there is no p here and f naught is constant. So derivative of f naught is 0, so f naught is missing here. Derivative of p is 1, so 1 into delta f naught. Derivative of p square is 2p, derivative of p is 1, and here derivative of p cube is 3p square, derivative of 3p square, 2 will be here, so 3 2s are 6p, so that is 6p, and derivative of 2p is 2 into 1, that is 2. Derivative of p power 4 is 4p cube by power rule. Derivative of 6p cube is 6 3s are 18p square. Derivative of 11p square is 11 2s are 22p, and derivative of 6p is 6 into 1, so that is 6 into delta power 4 if not, and so on. As we know that in the previous slide that f prime p is equal to 1 by h and to d by dp of f of p. So entering this value, replace d by dp of fp by this whole side, so you'll get f prime p. So this is f prime p is equal to 1 by h and to this whole side. That is the first derivative of Newton forward difference formula. So we can find the first derivative of the function by using Newton forward difference formula by this equation. That is actually derivative by Newton's forward formula, the first derivative by Newton, that is the formula. So steps for Newton's forward difference formula to find derivative. These steps are already discussed in the previous chapter, that set of data will be given to you people. You need to write this data in the form of a table. Our table will be given to you. We will construct a difference table and identify f naught, delta f naught, and all those differences as we have studied. We will calculate HP and XP will be given, and then we will use Newton forward difference formula to find different order derivatives. Remember that we have derived the formula for the first derivative of the function, which is this one in the previous slide, that the first derivative of the function by Newton's forward difference formula is this one. And second derivative, you need to differentiate this derivative with respect to p again to get the second derivative. So second derivative will be just like this one. There is 1 by h, so second derivative means there is 1 by h square as discussed previously. So that is 1 by h square, and derivative of delta f naught is 0 with respect to p. There is no p here, so that will become 0. Derivative of delta f naught is 0, and derivative of 2p is 2 into 1, so that is 2. Derivative of 1 is 0, so 2 is here. Cancelling 2 and 2, we will get plus delta square f naught, which is this one. Similarly here, derivative of 3p square is 6p minus 6 into 1 plus 0, so 6p minus 6 into p, 6 is common in these two, so taking 6 common, 6 by 6 is 1, so that is p minus 1 into delta cube f naught. Similarly, that is 1 by 12. Derivative of 2p cube is 2 3s are 6p square, and derivative of 9p square is 9 2s are 18p. Derivative of 11p is 11 into 1, and derivative of 3 is 0, multiplied by delta 4 f naught. That is the second derivative by the use of Newton power difference formula. And the third derivative is this one. Whenever there is the third derivative, so that will become h cube, and derivative of delta square f naught is 0 because there is no p here. Derivative of p is 1, derivative of 1 is 0, so 1 into delta cube f naught is this one. Derivative of 6p square, 6 2s are 12, 12p minus 18 into 1 plus 0, so 12p minus 18, 12p minus 18, 6 is common in 12 and 18, so taking 6 common, so that will become 6 by 12. 6 by 12 is 1 by 2, and this will be 2p square minus 3 multiplied by delta 4 f naught. These are the three formulas to find the first, second and third derivative by the use of Newton's power difference formula. Let us solve an example by the use of Newton's power difference formula. You are given a table, the values of x and f of x are there, and you need to compute, you need to find first derivative of this function when x is 0.25, second derivative when x is 0.25, and third derivative when x is 0.25 by the use of Newton power difference formula. First of all, we need to construct a difference table. That is a difference table. How could we construct this difference table? That is discussed in the previous chapter. However, I remind you people that how could we construct this difference table. This value is actually second minus first, this value is third minus second, this is fourth minus third, this value is last minus this one, and you see here that there is a decimal sign here, and decimal signs are ignored in all those values. Remember that the decimal point is, after the decimal point there are 4 digits, so we will put decimal point in all these values by keeping 4 digits on right hand side. So these are 4 digits, so we will put point here. These are 4 digits, so point is there but we ignore it. These are 4 digits, so point is there. These are 4 digits and point is there. You see that these are 3 digits, so make it 4 by increasing 1 0 on left hand side. Here put 1 0 here, then a decimal side, so this minus 163 is actually minus 0.0163. This minus 159 is actually minus 0.0159. This minus 157 is actually minus 0.0157. That is one digit. We need to complete these digits now. I mean 4. So 4 can be written as, put 3 zeros in front of 4. So this 4 is actually 0.0004. This 2 is 0.0002, and the same thing is here. Minus 2 is actually minus 0.0002. That is the reference table. Now some basic things are there, that how could we identify f naught. Just look at this thing, that 0.25 lies between 0.0 and 0.5. So xp, this xp which is 0.25 is somewhere here. So the above value is x0 and below value is x1, and this value is actually xp. So in front of x0 there is f0, and the first difference is this one, the second is this one, the third is this one, the fourth is this one. And just look at this calculation. Xp is given to you, which is 0.25. X naught from table is 0.00. X1 is 0.5. Calculate h, as we have discussed this in the previous chapter, that h is equal to x1 minus x naught. So x1 minus x naught, this is 0.5. Calculate p in the same manner, xp minus x naught by h. So p is equal to 0.5. Now we need to find the first derivative, the second derivative, and the third derivative with the help of Newton's forward difference formula. So applying Newton forward difference formula for derivatives. First derivative is this one. That is the first derivative, as we have derived this formula in the previous slide. Write that formula and replace h by its own value. H is actually 0.5. Delta f naught is from table, p is 0.5. Delta square f naught is this one from table, p square 0.5 square, 6 multiplied by 0.5. Delta cube f naught from table, p cube 0.5 cube, p square 0.5 square, p 0.5 minus 3. Delta 4 f naught from table is minus 0.002. Now calculate, you need to calculate this equation. To simplify this equation, the second derivative is f double prime p, which is this one. Put the values, replacing h by 0.5. Delta square f naught from table, p 0.5. Delta cube f naught from table, p 0.5 square, p 0.5. Delta 4 f naught from table. So calculating these things, 0.5 square is 0.25, and calculating this, 0.5 minus 1 multiplied by 0.0004 is this thing, and this whole thing is equal to minus this thing. Calculating, we will get minus 0.0664. So that is the second derivative. And the third derivative is this one. From the formula is in front of you, as we have derived in the previous slide. You just need to replace h by 0.5, so that is 0.5 cube. Delta cube if not from table, p is 0.5 square. So square is missing here, put square here. 0.5 square minus 3 multiplied by delta 4 f naught is this one, and calculating this thing by your with the help of calculator, you will get 0.5 cube is 0.125, this is 0.0004, that is this thing, and this whole calculation 0.0048, that is the third derivative with the help of Newton's forward difference formula. Secondly, we are going to discuss Newton's backward difference formula to find different order derivatives. The criteria is the same, that set of data will be given to you people. You need to construct a difference table and identify those differences. Calculate HP and XP will be given. And now applying Newton's backward difference formula to find the first and second derivative as follows. That is the formula for the first derivative of the function. This formula is derived from Newton backward difference formula by differentiating that formula with respect to p to get the first derivative, and the second derivative is obtained by differentiating the above derivative with respect to p again. 1h will be increased, and derivative of delta f naught is 0 with respect to p. Derivative of 2p is 2, so 2 by 2 cancel, so we'll get nebula square f naught. Derivative of 3p square is 6p plus 6 plus 0, 6 is common, so 6 cancel, p plus 1 will be left, multiplied by nebula cube f naught, and the same thing goes here. That is the second derivative, which is obtained with the help of Newton's backward difference formula. So these two formula will be used whenever you apply Newton's backward difference formula. Let us solve an example. You are given a table of values, and you need to evaluate, you need to find f prime 0.85 and f double prime 0.85 based on Newton's backward difference formula. So start from a difference table. Difference table is being constructed. Identify x naught from here 0.85. 0.85 lies between 0.8 and 1, so this is x naught and this is x1, and that is xp. Secondly, f naught is in front of x naught and nebulas are upstairs, as we've studied in the last chapter. That is nebula f naught, nebula square f naught, nebula cube, nebula 4, and these calculations are obvious, as you know from previous example, that xp is 0.85, x naught is 0.8, x1 is 1. Calculate h, that is h. Calculate p, that is p, and using Newton backward difference formula, first derivative will be obtained with the help of this formula. You just need to replace h by its own value. H is 0.2. Nebula f naught from table, p is 0.25 multiplied by this 2 plus 1. Nebula square f naught from table, p square 0.25 whole square, 6 into p, and nebula cube f naught from table, p cube 0.25 whole cube, p square, that is p square 0.25 whole square, and p is 0.25. Nebula 4 f naught from table. So calculating these things, we will get f prime 0.85 minus 2.3950. So that is the first derivative by the use of Newton's backward difference formula. Now second derivative will be obtained by using the second derivatives formula with the help of Newton's backward difference formula. Replacing all those values, replacing h by 0.2 whole square, nebula square f naught from table, p is 0.25, nebula 4 f naught is this thing, p 0.25 whole square, 18 into 0.25, nebula 4 from table, and calculating f double prime, you will get minus 10.0585, and this is the answer of this question with the help of Newton's backward difference formula. The third one is Stirling's interpolation formula. Steps are the same. This is the old story. You need to construct a difference table and identify f naught, f minus 1 by 2, f 1 by 2, because these are the requirement of this formula. This is the old story, and the new story is we need to apply the Stirling's interpolation formula for second and first order derivative. So that is the first derivative. This first derivative is obtained by differentiating Stirling's formula in the previous chapter with the with respect to p to get 1 by h into this whole function. Second derivative, you need to differentiate this first derivative with respect to p, and 1 h will be increased. There is no p here, so derivative of this factor is 0. Derivative of this factor, this term with respect to p, derivative of p is 1, so that is sigma square f naught. Derivative of 3p square is 6p. Derivative of 1 is 0, so 6p divided by 6 is p, so that is p multiplied by this whole these two terms, plus derivative of 2p cube is 6p square minus 1, so that is 6p square minus 1 multiplied by 4 difference of f naught. So that is the first derivative, and that is the second derivative with the help of Stirling's interpolation formula. Special case of Stirling's formula for derivatives when p is equal to 0. When p is equal to 0, you need to put p is equal to 0 in the last two formulas to get f prime p in this form and f double prime p in this form. These are the two special cases. There is no need to derive these special cases. You need to replace p by 0 in the previous formulas and use the table to replace those differences, and you will get your answer. But if p is 0, these two are the simple forms of the previous formulas. Example is there. A table of values is given to you people, and you need to calculate first derivative of the function when x is equal to 0.6 and second derivative when x is equal to 0.6 by the use of Stirling's interpolation formula. Stirling's interpolation formula. Difference table is constructed. That is the difference table, and from this difference table you need to identify those differences. We see that xp is 0.6 and 0.6 is this thing. This is given in the table. So whenever this is xp, so this is your x0, this is your x0, and this is xp as well. So that is x1. In front of x0 there is f0, and above this f0, this is first difference of f minus 1 by 2, and below this f0, this is first difference of f1 by 2. Secondly, this is the second difference of this f0, which is in front of f0, and above this is the third difference of f minus 1 by 2 and third difference of f1 by 2. Again, this is the fourth difference of f0, and above this is the fifth difference of f minus 1 by 2, and this is the fifth difference of f1 by 2. So that is the table. This story is the same as repeated in the previous examples, but we see that p is 0 in this case. P is 0 here. So we need to use Stirling's formula. So use the special case of Stirling's formula. If you do not remember the special case of Stirling's formula, so just use the Stirling's formula and replace p by 0. It doesn't matter. Replace p by 0. So as p is equal to 0, so we use the special case. This is the special case of Stirling's formula. Replace the values, replacing h by 0.2. Nebula, sigma f minus 1 by 2 from table. This is from table, this is from table. All these values are from table. So calculate these values. You'll get first derivative 4.92, and the second derivative is this one. That is the second derivative. Replace the values from table, which is sigma square f0 is this thing, sigma 4 f0 is this thing, and sigma 6 is missing in the table. So we go just towards the fourth difference from the table. So that is 6.969, which is the second derivative when p is equal to 0. So I think Stirling's formula is simple to apply, but you need to remember that formula by writing that formula again and again. In this slide, we will derive the Bissell's interpolation formula for first and second order derivatives. Bissell's formula. We studied in the previous chapter that this is Bissell's formula. This is Bissell's formula, and multiplying factors containing p. What does it mean? Multiplying these, multiply p inside, multiplying these three factors, multiplying these four factors to get this equation. We multiplied p inside, so that is p square minus p. Multiplying these three, we'll get this thing. Multiplying these four, we'll get this thing. Why we multiply these things? Because we are going to differentiate with respect to p. So power rule will be used, which is very simple to apply. First derivative is given by this formula. First derivative is 1 by h into derivative of fp. This is fp, so that is 1 by h into derivative of fp with respect to p. So derivative of f naught is 0, and derivative of p sigma f1 by 2 is, derivative of p is 1, so this is sigma f1 by 2. Derivative of p square is 2p. Derivative of p is 1, multiplied by this factor, plus 1 by 6. Derivative of p cube is 3p square, so that is 3p square. Derivative of 3 by 2p square is p square is 2p, so 2 cancel, so that is 3p. Derivative of 1 by 2p is 1 by 2, multiplied by this difference, and similarly here. So this is the first derivative with the help of Bissell's interpolation formula, and this is the second derivative, which is 1 by h square multiplied by the first derivative. So 1 by h square multiplied by the first derivative of the function. You just need to differentiate this function with respect to p. So that is when you differentiate this function with respect to p, you will get there is no p here, so that will become 0. Derivative of 2p is 2. So 2 by 4, 2 2s are 4, so that is 1 by 2. 1 by 2 into this factor, so that is 1 by 2 into this factor. Similarly here, that is 1 by 6. 3p square is 6p minus 3 plus 0. So 3 is common and 6p minus 3. Whenever 3 is common, so that will become 1 by 2. So this is 1 by 2. And here 2p will be left, minus 1, multiplied by this difference. And here that is 2p cube is 6p square, that is 6p, and that is 1, and that is 0, multiplied by this factor. So that is the second derivative of the function with the help of Bissell's interpolation formula. These two formulas will be used. Example is there to understand the idea. The set of values is given, and you need to compute f prime, the first derivative and the second derivative, by Bissell's formula when x is equal to 0.63. Constructing the difference table and identify x naught. X naught is x is 0.63. This is actually xp. So xp is 0.63. 0.63 lies between 0.6 and 0.8. So that is x naught, and that is x1, and that is xp. These calculations are the older one. xp is 0.63, x naught, x1, h, p is 0.15, and Bissell's formula for first derivative is this one. From table, replace all those values. Replace h by 0.2, replace sigma f1 by 2 from table, and all those values from table to get this equation. Simplifying this equation to get this thing, and then 2.1676, that is the first derivative for xp 0.63. Second derivative formula is this thing, replacing the values from table and simplifying to get your answer. In all those formulas, we note that the criteria is the same. The process and criteria is the same for all the questions except the formula to be applied. The formula for Newton's power difference is different from the backward. The formula of Stirling's is different, and the formula for Bissell's is different. So formula, remember the formula, and the values from the table, from the difference table. That is the important step regarding solving those questions. The next one is Everett's interpolation formula for first and second derivative. We know from the previous chapter that fp, Everett's interpolation formula is this one. There is p in there is q in this formula, and we have studied that q is actually 1 minus p. Q is 1 minus p. So replace q by 1 minus p in this formula to get this equation. we have replaced q by 1 minus p to get this equation. Now differentiate this function with respect to p to get the first derivative, and then differentiate this first derivative with respect to p to get the second derivative. So that is the formula for first derivative, and this is the formula for second derivative regarding Everett's interpolation formula. So applying these formulas with the help of example, you are given a table of values x and f of x. F of x is calculated in this manner. Anyways, table is given to you people, and you need to obtain the first two derivatives, f prime 0.5, f double prime 0.5 by Everett's formula. Everett's formula. Difference table is in front of you. We see that fxp is 0.5 in both the cases. 0.5 is the same as x naught, so that is your x naught as well as xp, and this is x1. In front of x naught, this is f naught, and so on. These are the calculations, the older one, but p is equal to 0. So replacing all those values, Everett's formula, this is the first derivative regarding Everett's formula. Replace the values. We put p 0 in this formula. So whenever p is 0, you will get minus 2 by 6. Minus 2 by 6 is minus 1 by 3. And all those values will be, this formula will be simplified whenever p is equal to 0. Now from table, replace f naught by its own value. This is f naught. H is 0.02. This is sigma square f naught, sigma 4 f naught. This is f1, sigma square f1, sigma 4 f1. With the help of your calculator, you can simplify to get minus 0.64. So that is the first derivative whenever p is equal to 0. Second derivative, Everett's formula for second derivative is this one. Replacing p by 0 in this formula to get the simpler form of this formula. Now from table, just replace h by 0.02, sigma square f naught by this thing, and sigma 4 f naught by this one, and use your calculator to get the answer in this manner. So that is the answer. The second last formula of this chapter is Gauss forward difference formula to obtain the first and second order derivatives. We remember from the previous chapter that Gauss formula is this thing, fp is equal to f naught plus p sigma f1 by 2 and so on. Differentiate this formula with respect to p to get the first derivative. The first derivative is 1 by h into derivative of this function with respect to p. Derivative of f naught is 0 because p is missing here, and derivative of p sigma f1 by 2 is, derivative of p is 1, so this is sigma f1 by 2. Derivative of p square is 2p, derivative of p is 1, derivative of p cube is 3p square, derivative of p is 1, derivative of p4 is 4p cube, and so on and so on. So that is the first derivative. That is the first derivative, and we have simplified this equation in this form. These are the same up to here. 2 is common in these terms, so whenever 2 is common, so 2 12s are 24, so that is 1 by 12, and this will become 2p cube, 3p square, p, and this is 1. So this is the simpler form of first derivative regarding Gauss forward formula. Differentiate this first derivative with respect to p to get the second derivative, which is 1 by h square sigma square f naught. The derivative of this function is, derivative of sigma f1 by 2 is 0 because p is missing here. Derivative of 2p is 2, derivative of 1 is 0, 2 cancel, so this is sigma square f naught, and so on, so on. So that is the second derivative by the use of Gauss forward difference formula. So this and that are the first and second derivative regarding Gauss forward difference formula. Example is the same. Table of values are given. You need to calculate f prime 0.5, f double prime, make a difference table, identify xp, this is xp, xp and x naught are same, so this is x1, so again x naught is there, this is f naught, and so on. These calculations are the same. Just apply the formula, Gauss forward difference formula, and put p is equal to 0, because p, we have found p which is 0 in this above formula, to get the simple form. Whenever p is 0, so that will become 0, so this is minus plus minus 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 1 by 2 sigma sigma f1 by 2 minus 1 by 2 sigma square f naught, that is 0, so minus 1 by 6 sigma square f1 by 2. Whenever p is 0, so this is 1 by 12 sigma 4 f naught. So from table you need to replace sigma of 1 by 2 sigma square f naught, sigma square f1 by 2 sigma 4 f naught, to get this side, replacing these values and simplifying these values, you will get this thing, and the last one is this thing, and the very last one is minus 0.640. So that is the first derivative regarding Gauss forward difference formula. Second derivative by the use of Gauss difference formula is this one. Replace p by 0 here, and replacing all those sigmas, sigma square f naught, p is 0, so that will become 0, that will become 1 by 12 minus p is 0, so that is plus minus 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 1 by 12 sigma 4 f naught is this one. Calculating, you will get the answer, which is minus 0.2792. So that is Gauss forward difference formula for first and second order derivatives. The last one is the Gauss backward difference formula to find the first and second derivative. We know from the previous chapter that Gauss backward formula is this one. Differentiate this formula with respect to p to get the first derivative, which is this one, and differentiate this first derivative with respect to p to get differentiate this first derivative with respect to p to get the second order derivative, which is this one. This is f double prime p, so just remember this is p, so that is also p, this is p actually, so that is the second derivative, and this is the first derivative. The last example of this chapter, we need to find the first and second derivative by the use of Gauss backward difference formula. The same example is repeated, table of values is there, and you need to find f prime 0.5 and double prime 0.5 by the use of Gauss backward formula. Gauss backward formula. A table is constructed. This is the old story. How could we identify xp? This is xp, this is xp, xp and x naught are same, this is x1, so xp, x naught, x1 are there. We have calculated h by this manner, calculated p, which is 0. So Gauss backward formula for first order derivative is this one. Replacing p by 0 in the above formula to get the simple form, which is this one, and replacing sigma f minus 1 by 2 sigma square f naught sigma cube f minus 1 by 2 sigma 4 f naught, and calculate to get the answer. The last one is Gauss backward difference formula for second order derivative, which is this one. Put p is equal to 0 and get the simple form of this formula, which is this one, and replace sigma square f naught and sigma 4 f naught from the table to get this thing, and the second loss is this thing, and the last one is minus 0.640. 02792. So that is the last formula of chapter number 4. There are 7 formulas. All those similar formulas should be practiced for examination. The questions are easily solved if you have command on your calculator and command on the formula. So there is nothing else in the questions to solve. So be careful remembering the formulas and the use of your calculator for chapter number 3 and chapter number 4. In fact, the whole numerical analysis based on the practice of the calculator. So best of luck and pray for us. Allah Hafiz. Allah.